The objective of this lesson is to connect knowledge of repeated addition of unit fractions to multiplying a fraction by a whole number multiplier. This lesson builds on a previous lesson where students learned that any fraction is composed of iterations of a unit fraction. In this lesson, students will understand repeated addition of a fraction as multiplying a fraction by a whole number. What is a unit fraction? A unit fraction is one part of the number of pieces the whole is divided into. How then would we divide 7/8 into unit fractions? That would be 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. Let's take the yellow hexagon and call this our whole. Which pattern block would we need to show thirds? It looks like it will take 3 blue rhombuses to make the whole. Let's use this block to find what happens when 2 of the 1/3 blocks are added together and write the addition equation representing the process. If we use 2 1/3 blocks, that would be 1/3 plus 1/3, which equals 2/3. Could we write this equation as a multiplication equation? How about 2 times 1/3 equals 2/3? Let's try 3 of these 1/3 blocks. What is the addition equation and the multiplication equation for this model? The addition equation is 1/3 plus 1/3 plus 1/3, or 3 groups of 1/3. And the multiplication equation would be 3 times 1/3. What is the answer? We could have 2 possible answers, either 3/3 in fractional form or 1. How could we model this on a number line? First, draw a number line and label it with 0 and 1. Now divide the number line into thirds. 1 rhombus, or 1/3, represents 1 jump on the number line. The second rhombus represents the second jump of 1/3, and the last rhombus represents the third jump of 1/3. We can see the pattern that as the number of iterations of 1/3 increases, so does the number of addends in a repeated addition equation. Also, as the number of 1/3 iterations increases, so does the whole number in the multiplication sentence. This pattern is what we see with whole numbers. If we look at this comparison more closely, the first multiple of 1 is 1, the second multiple is 2, the third multiple is 3, the fourth multiple is 4, and the fifth multiple is 5. When we look at multiples of a fraction, in this case 1/3, 1 times 1/3 is 1/3, 2 times 1/3 is 2/3, 3 times 1/3 is 3/3, 4 times 1/3 is 4/3, and 5 times 1/3 is 5/3. The numerator of the total increases as the whole number multiplying the fraction grows larger. Why does the numerator change but not the denominator? When finding multiples, the number of pieces change while the size of each whole, in this case a yellow hexagon pattern block, does not change. The blue rhombus is still 1/3 of the yellow hexagon whole. Let's look at one more example. If we use the yellow hexagon as the whole, which piece would show 12s? The purple right triangle is 1/12 of the yellow hexagon. Let's model the first 5 multiples of the fraction 1/12. 1 times 1/12 equals 1/12. 2 times 1/12 is 2/12. 3 times 1/12 equals 3/12. 4 times 4/12 equals 4/12. And 5 times 1/12 equals 5/12. How would we show the first 5 multiples of 1/12 on a number line? First, draw a number line and label 2 tick marks with 0 and 1 at each end. Then divide the number line into 12ths. The first multiple would be 1/12, the second jump would be 2/12, the third multiple would be 3/12, the fourth jump would be 4/12, and the fifth multiple would be 5/12. The objective of this lesson was to connect knowledge of repeated addition of unit fractions to multiply a fraction by a whole number multiplier. We met this objective by having students use pattern blocks to build multiples of a fraction, as well as model multiples of fractions on a number line.